Hello and welcome again to another OpenShift Commons briefing. Today is part of a series Operator Hours, and the good folks from Crunchy Data have for a long time done great work around the operator pattern. And today we have Jonathan Katz here with us to talk about the high availability Postgres and a whole lot more on OpenShift. And we're going to have him do an overview of the topic and hopefully a little bit of a live demo, because we'll put him on the spot, and live Q&A. So if you're wherever you are, whether you're in Twitch or YouTube or Facebook or here in Blue Jeans, ask your questions in the chat and we'll relay them to him and have a conversation at the end about the future of PostgreSQL and all kinds of good things. So Jonathan, take it away, introduce yourself, and let's learn a lot more. Thank you.
Sure, thanks, Diane. Yeah, so yeah, very happy to be here. It's it's been a while since I've been participating in an OpenShift Commons. I'm looking forward to the point where we can all get together again in person. So just real quick, a little bit about Crunchy Data. All we do is Postgres, and all we do is open source. Very similar to Red Hat's model. We started historically focusing on how to securely deploy Postgres, which is very important in many enterprise environments. And then as containers became a big deal, and as Kubernetes and OpenShift became a big deal, we focused on how to deploy Postgres in those types of environments, which is a lot of what we're going to talk about today. And like I said, everything we do is open source. Everything I'm going to demo today, talk about today, is open source. We believe, the best Postgres solution is, the upstream solution. So, everything we try to do, we give back to the community in that regard. So, yeah, feel free to, ask questions throughout. I'm very active in the Postgres community. Actually, I have a slide on that. I've been using Postgres for about 15 years. I've been active in the community for about 10, actually a little bit over 10 now, mainly focused on advocacy. So for instance, we have the Postgres 13 major release coming out next week, and a lot of what I do is, geared towards, getting that release out the door. Before I joined Crunchy Data, I was involved in a few different startups in New York City. And of course, we use Postgres as the solution there, but my background is actually in application development, and I think some of the things we'll talk about today will reflect that. And for me, it was sort of my journey from application developer to understanding more of the systems administration side, and bringing that background of always being the accidental systems administrator in the various organizations I worked for. So, and beyond that, I just love the open source ecosystem in general. I've been very fortunate in my career. I've been able to use exclusively open source. So, it's great to give back in a variety of ways. So, maybe to back up a second, if we were in a regular conference setting, I would normally ask how many people are running Postgres, and then how many people are running Postgres in production. But I also like to take a step back and just talk about, what it takes to run a database, in an organization. It's one thing to play around with, a data system on your laptop and do some cool things on it, which, arguably is what I'm going to be doing in the demo today. But there's, more considerations when you're trying to run a database system in production. I mean, it's very similar to what you might do with OpenShift, where you have multiple, high availability nodes set up to make sure that if, one goes down, you're able to get your workloads over to another until the original node heals. And you need to consider this, when you're running Postgres. I mean, or even any database. I mean, databases are foundational in applications. They're storing your data, so you need to make sure your data is safe, it's stored securely, and you're able to retrieve it and retrieve it efficiently as well. But a lot of things can go wrong in production. For instance, your data might become unavailable. There could be a network outage. There could be, a rogue process that's, just sapping all the resources from the system. It could be any combination of things. There are many cases where, I would, commit a denial of service on my own production database. So there's the human error as well. So you want to make sure that your database remains as available to your applications as possible. But certain other things can go wrong as well. For instance, let's say I drop the users table. That's going to cause a very bad day. So we need to be able to restore the database, back to the point where the users table existed. Beyond that, you might be, using databases in your development environments that you do have one production environment, but, to develop, you want to be able to bring up databases for your team. So you want to be able to rapidly provision and, maybe rapidly destroy. You may also want to be able to create production or production-like data or scenarios for your developers to work through, for instance, to troubleshoot an issue that is in your production environment. So being able to clone and copy that data is, very important as well. And of course, if you have, various, data regulatory concerns, you want to be able to do that in a way that is safe and secure. You want to be able to, anticipate problems before they happen. So you want to be able to monitor. You might want to know that, oh, I'm running out of disk. I need to provision, more space. I need to resize my, PVC or, or PV. Maybe things are not performing as quickly as they could be. You want to be able to, troubleshoot and diagnose which are your slow queries, and try to optimize them. And of course, you need to be able to manage, who's able to access your data. Production, typically it's your applications or, a database administrator who might come in and troubleshoot things. And, you also need to make sure you're securing the connections. Are they over TLS? And, all the considerations around that. So there's a lot to consider. And, I sort of try to layer it that, there's, multiple ways to get there, that you do have your stock Postgres system, but you need to bring in an ecosystem around it. Now, Postgres has a lot of these things available in terms of, what's built into the core system. And this is, comes through really over 30 years of evolution of Postgres. I like to joke, well, it's not really a joke. I'm about the same age as Postgres. It's been around, for a hot minute now. And a lot has, it has, adapted and changed with the times. One of the reasons why Postgres has become very popular through the years is because of its license. Much like Linux, there's no single vendor. It's a very flexible license. No one can actually own Postgres. And the community has gone to great lengths to make sure, this is the case. Because of this, it actually, it's attracted a very healthy ecosystem of people contributing to Postgres. And through this and through real world use cases, recent Postgres releases have brought it to, feature parity with other proprietary databases. So I'll take an example from about 10 years ago, but streaming replication. And streaming replication is one of the foundational aspects for, creating a high availability system, that you're able to take your data from your primary server and copy it over, in an ordered fashion to your replica server, and in a way that's, fast and efficient. So that came about 10 years ago. And it was, the basic form is basically, as soon as I get the data changes, send it over. I have no guarantees if it gets there, but I'm going to try to send it over as fast as I can. Then came synchronous replication, which is geared towards workloads that are, require, that are write sensitive. For instance, I really don't want to lose a transaction. I want to make sure it's copied to at least one other place. That came, let's say, roughly 9 years ago. And, I could actually probably go into a whole spiel about the difference between these two replication modes, their trade-offs, etc. I'll save that for a later slide or perhaps a question. As Postgres evolved, further things were added. Suddenly you had cascading replication, where you could have a replica of a replica, which allows you to, push things out, even, more distributed environments. And I can actually tell you that the Postgres operator, which we'll talk about, supports that, supports that feature in one of its architectures. Eventually we got something called quorum commit, which is popular in the distributed consensus world, where basically you can say, as long as my, my transaction gets to at least, let's say 2 replicas, then I'm going to consider it written. And if not, I'm going to hold the transaction until I know it's, safely written to, a certain number of replicas. We also got logical replication, which, created, you can create some, really awesome things around that. But one of the important things is being able to online upgrade. So, going from Postgres, let's say, 10 to 12, I can keep my system online and basically, flip it over like that, reducing the amount of downtime that I need. And that's just one feature. This replication has been very important to ensure Postgres can stay available. Now, to properly use it, there's a few it does take some work to set things up. Similar to writing an OpenShift manifest. The feature is there, but you need to be able to fill it all in. And this is where using automation patterns like the operator can help with that task. The other thing is, Postgres, extensibility, beyond just having extensions themselves. And, we're going to talk about those today where, you can basically, add on to Postgres functionality while still maintaining, the open source core. There's a whole library ecosystem that makes it, super easy to manage Postgres, be able to, for instance, monitoring it or, handling, the HA in a really cool way. Beyond that, having, transaction safety, data integrity, ensuring that your data gets written to disk, being able to detect if your data is corrupted. This is the page checksum feature in Postgres. It's really made it, very trusted. And the question when I first started in the Postgres community, the question I got most often was, what's Postgres? And this was in the tech community that, people didn't really know what it was. And it had already been around for 20 years. The question I get now is not what's Postgres, but how do I do XYZ with Postgres? How do I deploy it in this manner? How can I use this feature? And it's really shown the evolution that not only does Postgres have a name recognition, it's being deployed. It's being deployed in mission critical ways. And again, with my open source community hat on, like it's just so cool to have really seen their evolution. And it really goes to the credit of the community and the feedback we've been getting into the community to make sure we can continue improving the product. So that is my spiel on Postgres. There, I was joking with Diane that I could probably talk about Postgres itself for at least an hour, and there still would be plenty more to talk about. But today, the goal is to talk about how do we run Postgres on OpenShift or Kubernetes, and in a way that can satisfy all the needs you need to be able to run it into production. And this is where operators come in. Operators, have really changed the way in terms of how you can deploy stateful applications on Kubernetes. And what do I mean by that? Stateful workloads really only have one job. You need to maintain state. Basically, if I modify, let's say I insert a record, let's say it's a financial transaction, I need to make sure it gets written to disk. I need to make sure that nothing's going to mutate that record in a way where it's going to invalidate the transaction or lose the transaction. I mean, that would be pretty bad. So we want to make sure that we're able to create a system that's resilient. That, let's say, my disk does, crash out, or the block, there's some corrupt blocks on the PVC I'm using, that I'm able to restore my data in a way and know that I didn't lose any of it. So in order to do that in Kubernetes, we need to apply more knowledge in general. And this is where operators can help, because operators can help encode specific information into your environment so that you're deploying your stateful service in a way that matches what it does. So Postgres does things one way, MySQL does things another way. There's from a high level they're similar, but the specifics in terms of how they work are different, and that's where the operator can capture that information. Additionally, to modify the state, it could be range for something very simple or very tedious. To create a Postgres replica is actually a little bit of a tedious process. It helps to have all of that automated, and it helps to have that automated in a way that is able to do it efficiently. Adding a user, on the other hand, is very simple. I can add a user to a database with one line of SQL, but let's say I bring a new DBA into the team and I want to give them an account to all the databases. Well, that's a little bit more tedious. And granted, if you've been doing DevOps practices for years, you can write your appropriate Ansible playbook to get that all set up. But then you have to think about that from a maintainability perspective, because you're creating something that may or may not be standard practice, and then you have to teach everyone in terms of how to do that. What operators do is that they create a consistent view of the world so that adding a user is the same no matter where you install the operator. And that's where this pattern is great, because with having a healthy operator ecosystem, suddenly we're able to create standard ways of taking actions on the various stateful services that are out there. And this leads to the final point of allowing automated managed workloads. Some of this starts with just being able to do the proverbial day two operations, handling high availability, having monitoring in place, having taking systematic backups, and so on and so forth. But as things continue to advance, and some of this is forward-looking, having smart systems, and some of these are already. And what I mean by smart systems, I mean being able to auto scale or auto tune themselves. And there's some services that can do that. And with Postgres, to be able to do with a database system like Postgres, to do things like auto scaling, you need to have a lot more knowledge because, what does that actually mean? Do I need to scale vertically? Do I need to add more RAM? How does that affect my Postgres configuration? Or, do I need to load balance things more? Is my workload really read heavy? How do I determine if it's read heavy? What are my scaling thresholds? And we have the ability to start amassing that information and start building out systems like that. But, that'll take some time. That said, with the way the operator pattern works, we're well on our way to getting to that point. So, I would say that concludes my spiel on Kubernetes operators and, tie it into a topic that's near and dear to my heart, which is the Crunchy Postgres operator. So as I said at the beginning, at Crunchy Data, everything we do is open source, and the operator is no exception. It's actually been open source since March of 2017. It's one of the early examples of a stateful operator. Currently, we're on our version 4.4. Actually, we have a 4.5 in beta right now. I'm going to demo a little bit from that today. This is the surprise demo I was informed about, but that surprise demos are all the more fun. It's level 5 on Operator Hub. It's a certified operator. You can go ahead, try it out today. And going back to that original slide, I mean, I do like the hippo wearing the kube hat, but the idea with the operator is we want to support all the features you need to run Postgres in production. And it could be a single Postgres cluster running in production, or it could be 1,000 Postgres clusters being managed by the operator. We've seen both use cases, and of course everything in between. And to us, it was important that we're able to do that. And I can go and read through the list, but I'm going to cover a couple of things I hadn't touched on yet. Elasticity. Being able to add and remove replicas. They could be for high availability purposes. They could be that you need a read-only replica. Your business intelligence person comes in and wants to perform some read-only queries. And it could be for load balancing as well. It just depends on what your use case is. But the idea was to make it easy that I can add an additional replica just by typing pigo scale hippo or whatever my cluster is. Leveraging, one thing that's important too is we can leverage, Kubernetes and OpenShift native objects to, create a very sound system. So Kubernetes has this concept of pod anti-affinity, where you can assign rules to say, hey, I want pods of these types to ensure that they don't deploy to the same cluster. You can require it and say, like, don't schedule the pod unless they're specifically deployed to different nodes. Or you can prefer it and say, try to schedule the pods to different nodes, but if you can't do it, no, it's okay, schedule it to the same node. But the reason we went with that is to make sure that there's a higher probability or guaranteed probability that you can schedule your Postgres instances to different nodes. Disaster recovery, we use an open source tool called PG Backrest. It's actually something that we support very heavily, and the reason is that it was designed for terabyte scale databases. That they saw the authors saw an issue where it was difficult to create an efficient backup solution in Postgres for very large databases, and sure enough, they've solved that problem. One thing that we've done with the operator is that we've built our disaster recovery solution around it. It's great. It's one thing that I've always looked to employ wherever I've been employed since the existence of PG Backrest, and we're very happy to help drive further use cases to it. In fact, one of the benefits of doing everything open source is that the operator does help, and based upon the feedback we get from the operator, it does help drive features being added to PG Backrest. So one of the big ones was being able to expire backups, or create a time-based retention policy, saying like, hey, I want to keep this full backup for 21 days. That came from direct feedback of people using the Postgres operator, and ultimately it was upstreamed into PG Backrest. Administration. One thing that I may or may not attempt to demo is being able to use the popular PG admin tool, which is a graphical user interface to administrate your Postgres instance. And PG Monitor, which is a connection pooler. One of the known limitations in Postgres is that the number of connections you have could have an impact on database performance. It has to be a fairly large number. That said, first off, there's actually a big improvement for that coming in Postgres 14, but that's at least a year away. And until then, there was PG Bouncer, which is, a connection builder. So basically, you could have, several hundred connections coming into PG Bouncer, and then, scale down what actually goes into Postgres. I've deployed it, multiple times in my career. I was very happy that, we were able to integrate it into the Postgres operator. And there's some added benefits of PG Bouncer as well, where it can do connection state management. We're basically doing a failover scenario. You can have PG Bouncer hold connections until the failover is complete and then resume them. Last but not least, and a big feature of 4.5 is a full support of the open source PG Monitor, which includes lots of wonderful charts and graphs that are essential for monitoring Postgres clusters, which we'll touch on in a little bit. So why should we use an operator? Well, there's a lot of really good points on that. I'm just going to brush on this slide because I'd rather get into talking about some of the architecture and the nitty-gritty details of how the Postgres operator works. But automation, standardization, ease of use. I think I tried to discuss this as well as I could before. I do want to emphasize the ease of use. The idea that, we have, a fairly simple API, or you manipulate things from the CRDs, or, even like a CLI UI, our Pico command line interface, is very popular because I can just do Pico create cluster hippo, boom, I have a Postgres cluster. Pico create cluster hippo replica count 3, I have, a high availability cluster there. I've also been involved in developing a UI around the operator, and it's that's a longer story for another day. But by creating like a standard interface, it's very easy to create even more robust applications around Postgres. Scale, and when I talk about scale, it's not just saying like, oh, the Postgres operator can manage 1,000 Postgres clusters. It's also scaling your workload. And this is something I always looked at when as an engineering manager is, how do I scale our processes across the team? Can I create something that's repeatable and standard that everyone can be able to do and interface with? So that that's an important thing to consider as well. We certainly done engineering type things to ensure the operator itself can scale. For instance, our multi namespace support. We at one point we were hitting limitations on it, but thanks to one of our very smart engineers, we can handle, I know, easily northward of 100 namespaces in the multi namespace mode. I don't know, we haven't really pushed the limits of it yet, or we haven't found the limits, I should say. Security. And this is the cool thing about running Postgres in containers, is that you naturally get a certain level of security there, and such that you're in a sandbox environment. And that actually affords you to do, if you want to do some, cooler things like give people super user within your container. And by that, I mean Postgres super user, not a root within the container. Yeah, you can do that, and there's lower risk to that. I might have my own opinions on what you should be doing, but the idea is that you're operating in a more of a sandbox environment, and that affords its advantages as well. And just having the process isolation built in too, certainly helps when you're running in a multi-tenant environment. And the flexibility, and this is one of the first things that really attracted me to what we were doing with the operator, is that as long as you have a node, you can run it anywhere. It doesn't matter where your OpenShift nodes are deployed. You can run a Postgres cluster there. And that's really cool. And I think in this regard, like I can I'll speak for the Crunchy operator, but the operators in general create that unified layer where so long as I have something that speaks Kubernetes or OpenShift, I can deploy my workload. Same with if I'm running OpenShift, as long as I have an OpenShift node somewhere, it doesn't matter what cloud provider I'm on, what hardware I'm running on, I can deploy there. So that's really cool. And one thing that we do when testing the Postgres operators, we test it, we test in all sorts of places. We run OpenShift in one environment and OpenShift in another environment, and for the most part, it just works. So that's that's my pitch for operators in general, let alone the Postgres operator. So how does it all work? Well, I would say just look at the diagram, but going into a little bit, part of the operator pattern is that you have these things called custom resource definitions. And, from my application developer perspective, I consider that your database schema. Your custom resource definitions, or CRDs, basically store the infrastructure of what you're going to deploy. So we have one called PG cluster. What PG cluster stores is essentially your definition of your Postgres cluster. It says how many replicas do you want? What port do you want to run it on? Do you want a PG bouncer with it? Do you want to collect metrics with it? And so on and so forth. And from that PG cluster, you should be able to deploy a Postgres cluster anywhere. If somehow your whole Kubernetes environment gets wiped out, well, if your data gets wiped out, then that's a different story. But let's say all your deployments get wiped out. Well, I should be able to redeploy a Postgres cluster that looks exactly like what you had before from that definition. Excuse me, drink of water. So from there, what the operator does is the operator reacts to what's been added to a custom resource definition or any changes in the custom resource definition, and then applies those changes throughout your OpenShift environment. We've layered a few things on top of that. We have an API server that makes it a little bit easier to interface with the custom resource definitions as it aggregates that information together. And that's actually what the Pico command line client uses as well. Speaking of, we have a command line client called, Pico, which is, I call it the Pico client. It works across different operating systems. And it makes it super simple to create Postgres clusters, manage Postgres clusters, modify them, take backups, whatever it may be. And we'll demo some of that. We also have a scheduler, which is used to schedule backups amongst other things. And this is great because you should always be taking backups. That's another thing I always emphasize, that if there's one takeaway from this talk, please take backups of your Postgres cluster. You never know when you will need them. And maybe to further emphasize that, there was a time in my career, like one time where I really had to make a point in time recovery. Like, there was something where we had to, get the data back to a certain point in time and replay it, and find certain things. And thankfully, not only did we have backups, we had our transaction history, back to that point, and we were able to, solve the issue. But please take backups. It's so important. So just finishing up, this diagram. The most important thing when you're running a database is your storage. No matter what it is, your storage is going to be your bottleneck. Storage has gotten much faster. Like SSDs were one of the greatest things that happened for database workloads. The one trick with SSDs, particularly back in the day, was reliability. But the recommendation would be always have run in like a RAID 10 mode. So that all said, the interesting thing in the Kubernetes and OpenShift ecosystem are the variety of storage classes available, or even people who we have cases where people just use host path storage and pin their Postgres clusters to a single node and ensure everything gets right into that node. But storage selection is a very detailed, involved topic. The various storage classes have certainly improved, even since I started at Crunchy Data, and it's interesting to see what's happening there. Our team stays on top of it to for our various testing and compatibility purposes. But you should always consider what level of storage you need based upon your workload. Not everyone needs the latest and greatest and most expensive storage for their databases. I mean, am I biased? Like, yes, of course I love playing with like the latest and greatest and fastest storage, but you might not necessarily need that. But if you do, you should know how you're able to, optimize using Postgres, with your various storage layers. So let's talk about high availability, which was the original topic of this this chat. This is a really important slide because this explains how high availability works with the Postgres operator, but it also shows like how cool it is. Whenever we get tickets about support tickets around high availability, one thing we always try to ask is, how's your high availability set up in your Kubernetes or your OpenShift environment? Because your Postgres high availability with the Postgres operator is tied to your Kubernetes high availability. And this is a feature, and this is why it's really cool. So Kubernetes and OpenShift are backed by their own distributed consensus storage system. It could be etcd. And etcd has its own high availability system built in. But the reason why we leverage this is because it minimizes the amount of Postgres nodes you need to deploy for high availability. So let's take the raft algorithm. Now, the RAF algorithm says, you always need an even number, sorry, you always need an odd number of nodes to be able to get high availability. And I believe, as I recall, the recommended number is 5. So running 5 Postgres databases, particularly, let's say they're multi-terabyte, that's a very large footprint. Even running 3, I mean, I like to recommend 3 as the number that you should run, but that's still, if you have 10 terabytes of data, that's at least 30 terabytes that you need, plus backups, plus your various logs and WAL and other things that you need to store. So there's gonna be a lot of data floating around. By leveraging the OpenShift back storage system, you actually only need to run 2 Postgres instances to get high availability. And that's what's really cool, because it does help you lower your footprint, but you can still maintain a safe distributed consensus high availability. So, what I showed here was, I just showed 3 nodes here. And these are the actual OpenShift nodes, because the other thing you need is a PG backers repository. That's the third component for the high availability. And the reason there's 2 reasons why we leverage that. One, of course, you need to take backups. Remember, the one takeaway from this talk is please back up your database. 2, PG backups is actually used in the self-healing process. So let's say my primary goes down, and let's say it's down for several minutes. The replica is promoted. We want to bring the primary back into the fold, or the old primary. It's going to be a replica, but we need to be able to catch it up to where the primary is, so it can rejoin as a healthy streaming replica. We can leverage the PG backrest delta restore feature to efficiently copy the information into the failed replica, effectively reprovisioning it, bring it up to speed, and then tie it back to the primary. So not only does PG backups serve as part of the disaster recovery system, it does play a role in high availability as well, which is really cool, because we can leverage all those efficiencies that are put into it to quickly heal components within the system. So the takeaway from this is that the Postgres operator does provide high availability, but it's leveraging it from Kubernetes and OpenShift, which is, like I said, is really an advantage. I guess the other thing I should point out is that the operator itself is not providing the high availability, because that would make it a single point of failure. The Postgres instances themselves are providing the high availability. They're communicating with Kubernetes to make sure that to basically determine, if there needs to be a leader election because, a primary is down or unreachable, or, whatever it may be. So disaster recovery, how does it work? I would say that it works in, in a pretty cool way, and in what we can support. So we can actually, we support a multi-repository setup. And what I mean by that is that you can push your archives, your backups to, a PVC that's somewhere within your local OpenShift environment, or, you can push them to S3 or an S3 compatible storage system, such as MinIO. And you can actually support both at once. And that's cool, because, you can guarantee that your backups are being pushed to multiple places. Additionally, you're able to schedule backups as well. And, the easiest way to make sure you keep taking backups is to keep scheduling them, or to have a schedule of them so they can keep being taken. However, you should also make sure your backups are being taken, and you should monitor everything else. And, this is a feature that, that I'm previewing for, the upcoming operator release that's, coming out towards the end of the month, is our integration with PG Monitor. So what PG Monitor provides is a series of Grafana dashboards that can be read in from a Prometheus database, and it basically shows you your overall health of your database. And it can track things. Well, it tracks a variety of things, and probably to go into that is a full talk in itself. But it's essentially a curated list of the key metrics you need to keep an eye on to try to anticipate issues with your system, or that will give you the overall health of your system. So, for instance, if you're supposed to take daily backups and the backup's not taken, the top bar that you see on the screen is going to go red. You can drill it down to your specific databases or specific pods within your cluster. But the idea is that you have all these key metrics there. Take another one, replication status. This helps you detect, what your replication lag is. If you're using asynchronous replication, this could become an issue because if your lag is too much, you're at risk for data loss if there's a failover event. So you do want to keep an eye on that. The other thing with this is that this works with all the upstream components. So if you already have a Prometheus instance that's set up that you're using to aggregate your metrics, you can plug in the Grafana dashboards and be able to pull from that Prometheus instance. One thing that I do want to show here, actually, first I'm gonna get a drink of water. One of the dashboards that I want to show is actually related to getting pod-specific metrics. So this was an issue that we had run into for a long time, was that some of the key metrics when using a Postgres database are related to your actual pod utilization. And we had a hard time trying to pull these metrics out in a consistent way. One of the people at Crunchy Data, Joe Conway, he's a Postgres committer, major contributor, and now a container enthusiast, wrote an extension to Postgres called pgnode-mx that can actually reach inside the pod and pull the information out of the various C groups. And it works for C groups version 1 and version 2. And it can pull out, this specific, let's call them the OS style metrics from that particular pod. So I can see, this, primary has as much disk activity, or, it's currently, CPU is currently pegged at 100% of it. Do I need to raise the limit? And help answer questions like that. And this is probably, you're not supposed to pick favorite features, but this is the feature I'm most excited for the upcoming release, because particularly, as an application developer, this is where I always started when troubleshooting my systems, because to me they were the stats that made the most sense. If memory utilization is getting out of control, I knew that there's probably there might be a runaway query and I should look into that. Same thing with if CPU is at 100%, let me try to find the process that's doing that. Oh, maybe it's a really poor recursive query I ran, which was often the case. I could then go in and fix it. I mean, kill the process and then fix it. But yeah, disk usage, I'm at like 80% disk usage. Is there an unacknowledged replication slot somewhere that's, causing, too many wall logs to be retained? And of course, it's nice to be able to look at the charts and get all of this information, but it's also good to be alerted to problems. And we've pulled together our favorite alerts that will tell you, what kind of errors are going on. For instance, if high availability is, if you can't heal something's wrong, the cluster is inaccessible, and it's inaccessible for a certain period of time. Let's send a critical alert for that. The way I triggered this alert originally was I did a very terrible thing. I removed the data directory from Postgres and just totally made the instance unusable, and that was good enough to trigger the alert. I was actually not running it as a high availability instance, which is why it was impossible to heal. So that being said, we've added a variety of alerts. Is your disk filling up? Is a replica? Is it lagging too far behind? And so on and so forth. And we hopefully you find these useful, and I hope you never have to respond to one of those alerts. So last but not least, in terms of the walkthrough demo, then we'll try a live demo. Adding the ability to administrate your database from a user interface, in this case, a pgadmin. We actually created an integration where we're able to tie the Postgres user accounts to pgadmin and keep them all in sync. So that way you can log into your pgadmin instance and administrate your Postgres database. So we tried to check all the boxes in terms of not only having the day 2 administration options available, but make it very easy for the people who do the daily Postgres work to be able to interface with their database. So let's do this. Let's create this high availability cluster with monitoring and connection pooling and all these wonderful things with one command, because that's really the beauty of all of it. Of course, I need to figure out how to share my screen again. A moment.
Well, you're sharing your kitchen nicely, so don't worry about
Excellent.
that. And
Excellent. This is your typical New York City kitchen. I have about, I think I measured, it's like 2 feet wall to wall. Okay. Can you see a terminal window?
yes, we can indeed.
Awesome. So so first off, I went ahead. I created a Postgres cluster because I think we're gonna do have some fun. So let's see. So we have a Postgres cluster. Let's inspect it a bit. So first off, Pigo. Pigo's, we call it the command line client for for interfacing with the Postgres operator. I mean, you can interface with the custom resource definitions directly. We find this very useful to use the command line client. And there's a bunch of different things. For instance, I can test if my cluster is up. I can see the current disk utilization. I can scale it. Well, first I can introspect it. I can check on the health of my backups. I take another backup because why not? And I can scale it up. So yeah, so the Pigo client is, you can see, is a Swiss Army knife for being able to handle all these different operations within your daily Postgres environment. So while that's going on, to show there's nothing up my sleeve, I'd also created a PG bouncer, which I've been connecting to. Here it is. And I have a port forward set up to it. You don't need to worry about reading the screen since it's just a port forward. I also added some data to my Postgres database to to basically bootstrap it using a tool called pgbench. So what I'm going to do is I am going to start writing data to my database using pgbench. And I will also say this is truly a live demo because I'm going to do something I did not test beforehand, but I want to see if it works.
Hey,
right,
Jonathan,
so
how often does a live demo actually break on you?
So typically I rehearse them, so the probability is very small. This is uncharted territory. But in this case, I'm going to try to purposely break it. What I'm going to do is I'm going to kill the primary node while we're running pgbench, and we're going to see what happens. So first off, let me find an available terminal window where I can do it. So I realize the font's probably really small here, but what I'm going to do is I'm going to run a delete on the primary node. Look at that. So clearly we had the server connection crash, but it reconnected just like that. So yeah, I'm gonna put this into the background so it keeps running. So what's going on? So let's do a test on Hippo. So we can see that our primary and PG bouncer are up, and the original primary was this node, the Hippo blah 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 blah. The new primary is Hippo ACGJ. So high availability worked. That we quickly even though we deleted the pod, which things can happen in kube world, in OpenShift world. So maybe the pod does get rescheduled or deleted, but it came back up. The interruption was very minimal. That's pretty cool. That's you can't get much better with high availability on that regard. Again, what I mentioned earlier is that if you want to avoid transaction loss, you need to have synchronous replication set up, which is something that we do support from the Postgres operator. Here, let me stop pgbench because those messages are getting tiring. If I want to create a cluster with synchronous replication, I would use the sync replication flag. Now, I mentioned that I talk about the trade-off of that. The problem with synchronous replication as it stands today is that if your replica goes down, so not your primary, if your replica goes down, technically your primary goes down because you need to guarantee that your writes are getting to the replica. Now with Postgres 10 and beyond, this is solved with quorum commit. And I believe, I haven't tried it myself, but if you do some of the, advanced configuration with, a Postgres operator instance, you can probably get the quorum commit. I would also caveat your mileage may vary, but the quorum commit, you can make it a little safer to deal with synchronous replication in the sense of that, there's still likely a performance penalty. There isn't likely. There is a performance penalty still using it because you need to guarantee that your writes get to whatever number of Postgres instances that there are. But it's not necessarily going to cause a downtime, much like if just a single replica goes down, your primary goes down. But that said, if there's certainly workloads that need it, and you're willing to pay the performance hit because you're guaranteeing that your writes are going to be in multiple places. I'd also say leveraging PG backups the way we do does help ensure that your writes get pushed out to the backup repository as well. There's always a little bit of a delay because you're dealing you need your full write ahead log record written before it goes out there. Some of the other things that are cool about this, other than showing that high availability actually works, is let me see if I can create a PG admin. So it'll take a few minutes to come up, but we'll try directly logging into the database via PG admin if I'm able to get all my commands correct, because again, uncharted territory. Maybe to cover a couple of the other cool features. You're able to tune your memory settings, tune how much CPU or RAM you want for a particular node. If you decide that what you originally deployed your cluster with is not sufficient enough, you can update it later. What else can you do? You can add table spaces. Table spaces are good if you want, there's a variety of reasons where you'd want to use a table space. So a table space is an additional external volume that you're attaching to your Postgres instance, for multiple purposes. One, it might just be a very large table or a very large group of tables, or a very large database that you don't want to attach to your main Postgres data directory. It could be that, you want to take advantage of, super fast storage for, a particular data set. It could be that you just have a lot of data and you need to spread it out amongst multiple PVCs. Now, the use cases do vary. So you're able to add table spaces to operator Postgres clusters, operator managed Postgres clusters. You set the size of the PVC that you want. You can do that on a one-off basis. So what other cool things? As you can see, there's a lot of flags. I do encourage you to read the documentation. I've tried to write the documentation in a way that tells a story that gets you going to where you need to go. As always, because it's open source, patches are welcome. People certainly do like to leave their opinions on the documentation. We also support an easy way of setting up TLS connections. This is, probably I only lightly touched upon this earlier. TLS, of course, is a very important part of being able to encrypting communications, make sure people aren't eavesdropping. We try to make it as easy as possible. You just have to provide, a key cert pair, and you're good to go. You can also force all connections to be over TLS by using the TLS only option. So I've probably stalled, I hope, long enough. There should be a PG admin deployed. There is. Let me see if I can port forward to it. So. Cool. So one moment, I'm going to make sure I actually did the port forward correctly to my computer. Yep. Alrighty. So now I'm going to shift my screen one more time, or maybe two more times. All right, so this is pgadmin. It's, as I mentioned, it's a popular user interface for interfacing with Postgres. So I'm gonna create a new user. Call the user Hippo. And voila. So this is cool because, this syncs with the administrative dashboard. I can, very easily log into my databases and see, I forgot which one I ran those, the PG Bench tool on. Mostly because I want to be able to run some queries against it, but I forget where I ran it. Here we go. All right, so yeah, so here's all of our data. We could try to query against it, or I'll probably, because I don't remember the syntax, I can create a table right here. Insert some data. Then query it. And just like that. And, again, what was really nice is that, I was able to, run a command on the operator and then, have everything, synchronized into the pgadmin interface. So, it's these things that are convenient, and it's, creating ways of, systematically being able to, to be able to, manage a whole wide variety of different Postgres workloads and needs. So I think with that, I will return to the slides. So first, we actually saw this whole thing created. And yeah, I mean, that's really, that's really all I have. I can, try to go ahead and, do more live demos, see if I can actually break myself. If I try to deploy the monitoring suite, I will break myself because I found something, incorrect in my configuration. I still haven't figured out what it is. But if I can get that working, it's actually pretty cool to see all the charts and dials going. But yeah, I think with that, I'm happy to take questions.
Hey, Jonathan, it's Mike here from Red Hat. How are you?
Hi, Mike. How are you doing?
I'm doing really well. Interesting demo. It's always good to see the inner workings of something so cool. But I manage relationships with lots and lots of software partners here at Red Hat, and it seems like there's just database vendors coming out of the woodwork everywhere. Are they all the same? Meaning, like, how is Crunchy uniquely positioned out there to be better than the other 10 database vendors that are all popping up everywhere?
Yeah, so look, there's all sorts of different solutions out there to how do I store my data, and it's certainly something I've seen through the years. And again, I'm biased. I've been using Postgres for 15 years. I've been deploying it successfully in production for 15 years. I was running Postgres, even before there was replication or like any high availability guarantees. And I think one thing that I love about it is that it's a very strong and healthy open source community. Similar to the way Linux is, similar to the way Kubernetes is. And one thing that I've liked at Crunchy is we have adopted the Red Hat model, and we found and we find that we like the fact that everything we do is open source, and we're able to support open source. That we can make the upstream the best stream, so to speak. So I think what I like about Crunchy is beyond that, it's how we do focus on what I said in this original slide. Beyond open source, it's adapting to the modern technologies that are out there, ensuring that we continue to make Postgres work efficiently on OpenShift, and the focus on security. A lot of what I found with data security through the years is that everyone wants it, but they really only employ it to ensure that they're compliant with whatever regulations that they are. And if you find that you're not doing things to keep your data safe and secure, you can actually run into a PR nightmare when data is breached. And data security is a whole topic in itself. We could probably spend several hours on it. And I think one thing that we try to focus on is not only how to mitigate the risk of threat, but how to deal with what happens should there be a breach, and ensuring that you can minimize the overall damage of that. So that's what I'd love. That's what I like to say about Postgres and Crunchy. It's the fact that we love the upstream, and that's what we want to support.
Thanks. I got one other question, the completely other side of the table though. Crunchy data. Where'd you guys come up? Where'd you guys come up with it? We always hear lots of interesting stories about how different companies select their name and the hidden meanings of why of the name and so forth. But why Crunchy? Why Crunchy data?
So interesting. I thought you would have asked about the hippo, because I think that's that's the bigger urban legend.
Well, I think that's part of it. It's like there is a hippo Crunchy. How does that work?
Yeah, so there's many urban legends around this. I think Crunchy data actually came out of a meeting where someone described what our founders were working on as very crunchy. So that's maybe the urban legend for that's a little less, but the hippo has many stories. And the one that I choose to believe is that hippos are fiercely protective of their watering hole. And given Crunchy's data roots are in the security space, having an animal that is very protective of your core asset, the watering hole, your data lake, if you will, gives a strong sense of assurance that we're looking after the integrity and safety of your data. Another one that I heard is that a hippo, when you see a hippo in the water, you only see its eyes, but there's a whole lot going on underneath the water, and that's sort of like a principle of security, is that you might only see one layer, but there's a lot of other layers going on. There's at least 5 other urban legends I've heard around the name, but those are the 2 that I particularly like.
Gotcha. Okay. So what's next? What do you? I know we're just about out of time. How do people get in touch with you? I mean, do they just send an email to Jonathan, or call your house phone?
Well, fortunately, as you can see by, I don't know if it's still showing my kitchen or not. We're fortunate that that house phone is not actually connected to an outside line. But yeah, email me, jonathan.katz@crunchydata.com. You Twitter me at jcat05. Go to the website, crunchydata.com, see what we're doing. Plenty of people come to the actual GitHub repo, crunchydata/postgres-operator. Certainly get a slew of questions there. But yeah, that's the easiest to what's next if you want to get in touch.
Okay. And there was another question, Jonathan. I know, sorry, we're over time, but
go for it.
CRD.
Yeah.
Shannon was asking about, can you share your CR by any chance? And I was like, I'm not sure what CR is, but Shannon it's what you use to create the actual pods.
Yeah, so so all this is in the documentation. We have a section just on the custom resource. So yeah, the CRD is the definition itself. We in our documentation, we have examples of how you can create custom resources. I could show what one looks like real quick. One that's already created.
Yeah, sorry. If you have just the YAML, it's fine. Just kind of for the learning purpose, to spin it up is kind of easier. Have a sample. When you mentioned that documentation is at the access.crunchydata.com document, right?
It is.
Oh, the GitHub one.
It's the GitHub one.
The GitHub
Well,
one?
in GitHub, it's in the access.crunchydata.com documentation.
Okay. Yeah, I found that GitHub one and pointed to the Crunchy data, but I would just kind of want to get a quick start and grab your CR, and then I can just pop them in and try. Yeah.
Yeah. So this is an example CR. This is the cluster that I was demoing from.
And it is in the GitHub. What you're saying?
Correct. Well, correct. It's in our documentation. So we have an example for how you can create a Postgres cluster using a custom resource.
Okay.
You know, one of the reasons why we have the command line is, you know, it makes it a little bit easier. You know, it's much easier to type pigo create cluster hippo than, you know, fill out the CR. But that said, you know, we do provide examples for how to do it from, you know, using just, you know, the custom resource.
Okay, cool. Thank you.
Welcome.
All right, then. I think we came to the end of our hour here, and it was a bit of a tour de force, and I really appreciate that. So thank you so much, Jonathan. We'll have Crunchy back again in a little bit of time. I think next month we'll have some of the folks doing some spatial GIS, but this has been an awesome session. So thanks, Michael, again for arranging this, and Jonathan for sharing your kitchen with us.
Yeah, happy to invite people into our kitchen, but we can only fit so many.
Yeah.
All right.
Take
Thank you,
care.
Diane. Thank you.